Hey time travelers. Sorry for the homemade video. I don't have a whiteboard yet, so this is just gonna have to do for now. But I wanted to touch on substitution because it comes up in the web assign. Sorry, in the what is it called? Mastering Physics. And it's also just like a pretty important thing in physics, and I'll show you later how it actually shows up. So all substitution is when you have two variables and they're both unknowns, and so you use your different sets of equations in order to solve for both of them. So normally in algebra, if you have two variables, you're kind of you're out of luck, because if you change one variable, the other variable can move to make that statement true. So that's to say 2x plus y equals 3. If y is 4, x can be -1/2. And if y is 3, x can be 0. So with one equation, it's kind of out of luck. So all is to say it's kind of context dependent, but if you have multiple equations and you're given multiple pieces of information, you can almost always rearrange and substitute in order to get what you need. So I've set up a systems of equations, which is to say multiple equations, and we're just gonna work through it, and it's just gonna be a work process thing. So there's a couple ways to do this. The first way, which I'll show, is direct substitution is what I call it. And this is the most common one in physics. So I'm gonna put a little star by it. The other ones, they're just kind of, or the other one is just kind of a neat trick. And it can get you out of a couple of scenarios if you're trying to do math pretty quickly. So direct substitution is you are going to focus on one equation, and you're going to isolate your chosen variable. So for example, I'm going to choose the second equation, and I'm going to choose a. So we're going to write down 3a plus 5b equals 4. Alright, so now that we have our equation for a, in terms of b, we can substitute it directly into the other equation. If we are to substitute this back into here, I can show you, it just equals 0. As you see, this is why we need multiple equations. So we're substituting from one equation into the other equation. So that's just a thing to remember. Right, so we're going to take 2a plus 6b equals 5. Also, you don't have to do this, but this is the way I was taught for physics, is that you always start with your new equation in complete totality. You don't ever immediately substitute. That's just good practice. Of course, we've all had times where we just directly substitute. I've done it, you've done it, it's okay, but this is best practice. And so we're gonna substitute for a. So we have 4 minus b over 3 plus 6b equals 5. And then we just solve for b. Now that we have a numerical value for one of our variables, we can plug it into either equation in order to get what we want. So I'm going to plug it into the first equation because it looks easier. Alright, so now that we have our two numerical expressions, what's really nice about substitution is that you can instantly check with either of these equations whether or not you're right. So I'm going to do the second equation. And your check, so long as this is a true statement, you know that it is correct. So then we can say our final answer is a b equals 1, 8, I've seen it like this, but this is kind of untraditional. I think this is what your mastering physics asks for, though. How I usually do it is I just say a is equal to -1/8, b is equal to 7/8. And that way it's really clear what refers to what, and there's not a lot of confusion. The second thing, which is just like a neat trick, is called equation substitution. And it works kind of the same way. There you have 2a plus 6b plus 5, 3a plus 5b plus 4. Usually it works for a lot simpler things, but if you're in a pickle, I think this is just a really handy trick to know. You take the coefficient of the thing you want to get rid of, 3. Sorry, you cross the coefficients. So you multiply this by 2 and this by 3. So that way you have them in common terms of 6a plus whatever. So we have 18b plus 15b equals 15 and 12 exactly. And you're just going to subtract equation from equation. So you have 3b. I did my math wrong. Totally lied. You have 8b into 7. And then you can solve for a the same way you did here, and then you can do the check the same. I found that equation substitution can be really nice, but it doesn't have a lot of practical applications when it comes to like physics. So let's see what like a physics thing might look like. Okay, I made a little oopsies. So we're gonna redo it. So in a physics context, you're gonna be like asked to call what's called a symbolic derivation or equation. And all that means is that you have your wanted term and you have it exclusively in terms that you know. So for example, let's look at this diagram and say we're asked to find the final velocity. So what I always like to do is I like to give a given charge. So we are given our initial velocity, which is 2 meters per second. We're given a time in which it occurs, 3 seconds. We're given no acceleration, so we're not going to write that. And we're given a distance that happens. So we know the distance is 30 meters. And we want to find our final velocity. Now, if we look at our equation for final velocity, we see that we have an acceleration component. While we're given that acceleration is constant, we aren't given the number itself. So we need to substitute that with another equation so that way we can get rid of the acceleration. One thing that's really nice about substitution is that you are essentially finding a symbolic derivation for a in order to get rid of a here. And that's what's really nice about substitution, is that you essentially are getting rid of variables by putting it in terms of other variables. Oh, one note is that these are like kinematic equations. I don't think you guys will need to like worry about them quite yet, but they're really important in just describing motion. So I'm just giving you these two. You don't need to worry about them. Like, you don't need to memorize them for now. Just like, these are here for the example. They're not here for something that you like need to know right this second. So we're gonna take this first equation and solve for a symbolically, so that way we can put it into the second equation. So we have now remember that I will always recommend that you place out your equation first and then work. It's just good practice, but you know, those are my 2 cents. So we're gonna solve for a. All right, So now that we have our equation for A, we can substitute it into our second equation. All right, now that we have our final equation, we have our symbolic equation for this, which is to say we have what we want in terms of things that we know. And now is when you can plug in numbers. One of the easiest ways to like get points is to work symbolically up until you have your symbolic equation. Then is when you can put in your numbers. So we're just gonna, oh, I forgot the t out front, so this will cancel. So it is going to be velocity final is equal to 22 meters per second. Okay. And this, we can just do a mental check, is a lot. This is essentially, oh, holy Jesus. This makes sense as a number because if you are going from 2 meters per second to 22 meters per second, you're gonna be averaging like about 10 meters per second. And if you're doing that for 3 seconds, you're gonna go 30 meters. So yes, I hope that this helped, and I hope that this kind of shows you how you not use substitution, how substitution, like algebraic substitution, can be used in physics. And then I hope that this helps for your WebAssign stuff. Good luck, time traveler. You got this.